Welcome to Shiksharthi, and today's our topic is recurring decimal to fraction. So first let us understand what is a recurring decimal. If you write anything in this form like 2.34 bar, then that is called a recurring decimal. So what is an expansion of this? 2.34343434 and so on is the expansion of this. Okay. Now there are certain things which we need to know about recurring decimal, and then we'll discuss about how to convert this into fraction by two different methods. Okay. Now first thing we need to know about recurring decimal. Here you can see under bar there are two decimals which are recurring, like 34343434 is recurring. Correct? So that is called periodicity. The number of decimals which are recurring is called periodicity. So what is periodicity here? Periodicity is 2 in this case. So under bar the number of decimals which are recurring is called periodicity. So periodicity is 2. Okay, that is first point to note. And recurring decimals will be of two types. Recurring decimals will be of two types. One is called pure recurring decimal and the other one is called mixed recurring decimal. So two types of recurring decimals, my friend. One is called pure, the other is called mixed. Now what is the difference between these two? Pure, I can take the same example, 2.34 bar is the example of pure recurring decimal, and if I say 2.1234 bar, then it is called mixed recurring decimal. I think by observation itself you might have understood, immediately after decimal if recurring starts, then it is called pure, and after few decimals if the recurring starts, it is called mixed. Okay, so what is the expansion of the first case? The expansion is 2.343434 so on is the expansion for the first time. Second one, 2.12343434 is the expansion of the second case. So you can see here recurring started after 1, 2 and then the recurring started, and here the similar thing is 2.343434 and so on. Normally I can convert these two into fraction. How do we convert into fraction is the discussion next to us. Okay, so we'll convert a few examples of pure to fraction and few examples of mixed to fraction. Okay, so let me take the same example, 2.34 bar. Right now I'm talking about pure recurring decimal. Pure recurring decimal converting into fraction. Okay, so let me call this number as x. What is the general method given in schools? That I'll do it. X is equals to, the expansion is 2.34, it's 34343434 and so on. And so on is the expansion. And what is the periodicity, friends, here? 2. So I'll multiply this number with 100 on both sides. So I'll multiply this with 100x here, and after multiplying with 100, this is going to be 234.34343434 and so on, it goes like that. See, point to be noted here, why I should multiply with 100? Because the periodicity is 2, I should multiply this number with 100. If you see the periodicity is 1, for example, if x is equals to 2.3 bar if I said, then I should multiply by 10 on both sides. If it is x is equals to 2.342 bar if it is, then I should multiply by 1000 on both sides. So I should decide the number of zeros according to the periodicity of the given recurring decimal. Okay, after you subtract what you get, this is going to be 99x and this one is going to be 232 followed by all zeros. You can see 34, 34, 34, 34 all gets cancelled, and ultimately the answer is x is equals to 232 upon 99 is the answer. So that is what is the fraction value, equivalent fraction value for this one, 2.34 bar. So that's the method which is taught normally in the schools, and that is actually the method also to convert a recurring decimal into fraction. Now there is a small method, or we can remember this like a shortcut method, which we normally don't encourage people to go for a shortcut, but sometimes the shortcut method or the easy trick will be much familiar, much easy to adopt, and we can apply those things. For example, we have 2.34 bar, friends. What I do, I'll write the entire number without decimal, without bar. See, I have not applied any decimal or bar here. Listen to my words carefully. I should write the entire number without decimal, without bar, minus without bar whatever we have. Without bar. Maybe before decimal or after decimal. Maybe before or after decimal, without bar whatever we have. We have only 2 without bar here. So I'll apply 2 over here. Upon, what is the periodicity, my friend, here? The periodicity is 2. So I'll apply 2 9s in place of that denominator. And now after subtracting, it is 232 upon 99 is the answer. You can see the same answer, we got it here. Okay, so let me take some quick examples, more quick examples to give you some more ideas. Like this one, you see, example. And what is this? According to, as per the shortcut which we discussed, 1123 without decimal, without bar, the complete number, minus without bar we have 1, divided by periodicity is 3. I'll divide this by 3 9s. And now after you subtract, it's 1122 divided by 999. Now also be careful, in case if this number can be cancelled, the fraction, the numerator and denominator, is it possible to cancel? Denominator is a multiple of 9 and numerator is not, because the sum of the digits is only 6. So we cannot divide that by 9. So we can definitely divide this by 3. It is 3 times here and 7 times here and 4 times here. Upon divided by 3, it is 333. And further it cannot be divided by 3. So just leave it. And that is your final answer as the value. Is that clear, all of you? Let us have one more. 0.45 bar, for example. It's 0.45 minus 0 upon 99 is what we have to do. Okay, hope you now catch up some speed on this. So it is 45 upon 99. Both are multiples of 9. We all know it. So 5 upon 11 is the required value for this. Okay, 0.216 bar, for example. It's 0.216 minus 0 upon 999, we can say, which is 216 by 999, we can say. And now both of these are multiples of 9. This will be 24 times and this will be 111. And further they are divisible by 3. This is 8 times and this is 37 times. So my final answer to this, or equivalent value of this one, is 8 upon 37. So I was giving you some values for pure recurring decimal. Now we'll have more examples on mixed recurring decimals. What is mixed recurring decimal, friends? If I take x is equals to 2.1234 bar, for example. Okay, so this is the example of mixed recurring decimal. In general method, how do we convert this? First, what I should do, I should multiply this number with 100 so that the recurring starts immediately after decimal there. So 34, 34, 34 and so on. First, to make it divisible by, just multiply with such a number that the recurring immediately starts after decimal. That is one. Second, now what I should do, I should multiply this number with, see, after decimal there are how many numbers? 4 numbers. So I should multiply with 40 value of 10 power. So like we have 10,000 over here. And after you multiply, this will be 21234.34343434 and so on. The basic idea is to make the decimal side completely 0. Fine. Now, when you subtract, what will happen, my friend? This is 10,000 minus 100, which is going to be how much? 10,000 minus 100 is, this is going to be 9,900 x is equals to, you can see the complete decimal side will be 343434 will be gone, and then subtracting 21234 minus 212, 34 minus 12 is going to be 22, and this is 210. And final answer is x is equals to 21022 upon 9,900. Now check whether you can cancel these numbers by any value. Like this number is not a multiple of 9, the denominator it is. This is not a multiple of 11, denominator is 11 multiple. Both of them are even numbers. At the max I can cancel both the numbers by 2. So that I'll do it here. 210 will be 10511. Upon this number, when I cancel by 2, it is 99, 98 would be 49 times and then followed by 50. So this is what the final answer is of equivalent fraction for this. So this is traditional method which is taught in schools, and the method to convert a mixed recurring decimal to a fraction conversion we have done. Now some quick methods. What is the quick method here? If you remember the previous method what we did, I'll just give you a clear clue. This is 34 bar. We wrote entire number 234 minus 2 upon 99, and then we subtracted, cancel if it is required. This method, like same number 212 34 bar, how do we convert this into fraction, equivalent fraction? Write the complete number without bar, without decimal, same like what we did in the previous examples, minus, if you remember my words, I said minus the number or the part of the number without bar, maybe before decimal or after decimal, like in this case 212. 212 have no bar. So I should write the entire number without decimal, without bar, minus without bar whatever we have, upon periodicity is 2. So I should write 2 nines up to what we did same with pure recurring decimal. Additionally, there is only one thing what I need to do. There are 2 decimal values without bar. For that I need to add 2 zeros here. So that is what the point is. Okay. Now when you subtract, 34 minus 12 is 22, and 212 minus 2 is 210 upon 9,900, and when you cancel it, this is 105, a double 1 upon this one will be 4950 is what we have. You see the previous slide here, the same value we got it, and the same number by the shortcut also the same. Okay. Few quick examples. 2.134 bar, for example, this is going to be 2134 minus 21 upon double line, because the periodicity is 2, and there is only decimal without bar here, so I should add only 1 0 here. Is that clear? So now after you subtract, 34 minus 21 is 13. It is going to be 13, and then 21 upon 990. Since both of them are not even numbers, there is nothing to cancel. Further, are they both multiples of 3? Denominator yes, but numerator is not. So this is the final answer which I can get, which cannot be cancelled further. Let's have one more point here. One more example I mean to say, sorry. This is something like I have 0.1228 bar we have. Okay, 1228 bar. Steps, I'll read very slowly. Make a note of the steps. Write the entire number without bar, without decimal, minus without bar whatever we have, upon periodicity is 2, so I should take 2 nines, under bar there are 2, so I should take 2 nines, and there are 2 decimals initially without bar, so I should add 2 zeros at the end. This is the step. Okay, so we need to remember how to write this one. Now 28 minus 12 is going to be 16, 12 minus 0 is 12, upon 9,900 is what we have. As you can see, both of them are multiples of 4. This is going to be 304, and this number when I divide by 4, 96 will be 24 times, 30 will be 7, and 20 will be 5, and I guess further they cannot be cancelled. Yes, they cannot be cancelled further. So answer is 304 upon 2475. So overview of the same topic, there are 2 types of recurring decimals, pure recurring decimal and mixed recurring decimal, and both of them can be converted into fraction by traditional method and by the shortcut method which I have discussed with you in this video. So you can use any of these methods. There is nothing wrong with them, and this is one of the good questions what we get in normally exams. Okay, so keep practicing these kind of questions. Thank you all.